Hello and welcome to another episode of Getting into Git-Oxide. Welcome back, Sydney. I think you said hello. I read it from your lips.
I was muted. I did say hello.
And we are back where we ended up yesterday, nearly. Because we had failing tests. They do still fail. But we also had some weirdness going on. We did debug the candidates that we had so far, and they were totally off, like entirely wrong. Depth was 7, but should be 3. And I admit this bugged me a lot yesterday. And just, I think no more than 10 minutes it took to figure out what it is and also to fix it. And I committed this change. So we can have a look at what changed to now get the right number. So I removed all the debug printing, but it does produce the right value now. And let's discuss what that was. Yeah. Oh no, wait, that's the wrong commit. This is the one. And yeah, this is something that Clippy suggested to me. I think Git does it exactly the same way, and we kind of just copied it.
Oh, okay.
And of course you can do this as well. Put the negation.
Yeah, that's always a bit more readable. Sure.
Yeah. Thanks, Clippy. And I'm thinking, if you would have Clippy for C, I think most C code would also look better. But yeah, I'm happy that Rust has it. It's really thinking about it, all the small things accumulating that make Rust so great. Sometimes big things. Yeah, what else did I change? Oh, not so much. Yeah, this one, okay. Oh yeah, that was the thanks Clippy commit, so one more.
Okay.
Before this one. Okay, so here, all this ordering stuff, I removed it, like the time-based thing, because we don't, remember when I showed the traversal code and it only ordered the parents. It didn't order the whole list.
Mm-hmm.
And we are ordering the whole list, kind of like Git does. Like Git does the same thing. So I was thinking it's probably okay, but it doesn't do the same thing. This commit list is something different than what we have. It's different. Whatever it does, it doesn't just do time-based stuff, because Git gets to write, like on our, our test, every commit has the same time. So our time-based ordering kind of made the whole thing go kaboom. And this is why we didn't get what we wanted, because we didn't have topo order anymore. We had some order, and this is why it just didn't work. And this somehow works. I don't know why. Probably means they do something special with these parents somehow. And it doesn't look like it, but maybe it is.
But didn't we keep a topology by just sorting the two parents?
We did not. I mean, the traversal code does that. Sorry, not our traversal code, but the git traverse crate code.
Yes, okay. Mm-hmm.
That one does it correctly. This makes sense that works. But we didn't do that because Git doesn't seem to do it. It's just one queue or one list, but Git gets the right results. We don't, so I just kicked this out. And I thought it makes no sense to do anything. Topo order is enough for that, because topological order is just, that's all that's needed to see ancestries and stuff and do this check. So doing the additional work, even if it's not worth it, and I just removed that, and that felt pretty good. Look, no parent buffer anymore. Now the commit time is gone. It's really just IDs that we store here. Nothing changed here. This is greatly simplified. And does it do anything special? No, look, I think this is exactly the same. That is what it was before. If it's vacant, we insert the flags that we had and we push the ID. Otherwise, we just change the flags. So if we know that parent, we don't want to look at it again, but we add the flags that we've accumulated so far. And this is what kind of brings together multiple forks, brings it back together into the same parent or into the same commit. Yeah, and all the stuff to get the time is also done at gun, and that's it. That was the change. Just remove stuff that isn't needed, and then it worked as it should, because now just topo order traversal.
Okay. So the basic idea was correct. We just had a bit of a wrong idea at the end.
Yes. And it's easy enough to do topo order. I also wouldn't want to, we do have an iterator that does topo order for us. But I don't think using it here would be so great. Even though, yeah, no, we can't, I don't think we can really use it here, because we still need to know the parents, and then we have to kind of decode the one commit twice, because the iterator does it, and we would do it again. That's cheap. Decoding commits is really cheap, but there's always a copy involved of memory and so on. So long story short, it's probably best to just have this little topological iteration here, and we probably do that many times over for other appliances as well.
And this fact that we're not sorting the parents anymore, is there, the case when the name is exactly on one of those parents, that's probably the only time that this could affect the depth computation, right? Or does that not matter?
Yeah, but I'd say it changes the order of things, but ultimately the result should be the same. If you think about it, like if this is two branches here and they have a common base, and if I order topologically, you get this, and if I order by date, you get this, because this happens to be more recent or something, Like this doesn't change at all the relation between tags and the commits. It just changes visually, right?
That is true.
Because they're still in the same spot, everything. And by that logic, not sorting anything shouldn't make a difference. And it doesn't, I think. Like, I can't imagine why it would. It's just
it is hard to imagine.
Yeah, just something we find earlier than other things, but ultimately we traverse the graph anyway, so we get the same result.
Yeah.
And maybe the thing that they do maybe they do it by date, so that they are more like revlist, and revlist is also by date, and maybe that shows certain commits earlier and gives you the right result earlier, because you don't have to traverse that much. But this might have been useful before they implemented the finished depth computation thing, which finishes the depth computation, and then you do all the work anyway. So I think this is just some thing of the past here. 15 years ago, right? That was added. Let's see, how old? 11 years ago. So, and the finished depth computation? 15 years.
No.
So that's even older. Okay. I rest my case, but whatever, it works that way. So in order to assure it works, we could try to just get the first test going. And the minimal work needed to do that, I believe, for now, is to sort the matches according to the comparison here, which means depth and then found order. So we want the shortest depth, and if there's some of equal depth, we want the one who's found earliest. And I think this is where it matters, the date, because the date ordering, that affects how we find things, right? So this is the difference. So if it's ties, then the order by date matters. Okay, now we got it. Now we've got a reason to actually implement that. But I would first implement this sorting. Cool. Let's make it to do here, because then we can do it, but we do the ordering just based on the parents again, like the traversal does, and then this should work. then we do exactly what Git does. And that's the goal, to be correct. Okay, but now for the sorting here. So if you have no candidates, do we already know what to do? There's an option outcome. Okay, so I'll just implement this. Do we have a test for no candidates? So we can try that right away.
Don't think so.
No, not yet. Oh, yeah, the output format stuff. That's nothing we have to be concerned with. Can I just extract this? Yes, looks good. Typical use cases. Yeah, I think because the run up here is so big. Right now there's only, let me just mark a test case. No describe possible. Yeah, so no candidate at all. Would need this. We would write a test for that. Man, why am I so lazy? Maybe I can just quickly refactor this to get the to get this. I think this is what shows true professionalism, that you know your standard workflow, so you don't have to delay anything, but we can quickly do what you have to do, and it's all right. And
get the refactoring done, and then
yes,
get on with your life.
So this, yeah, certain things would have to repeat, but I guess we don't. For this test, we only really need a repository, and that's read only anyway. So yeah, and the commit. That's also depending on the test, I suppose. So yeah, just these two give us the repo. Okay. Very brutal unwrap, but that's okay, I think. It's also nice just having a function, then you shadow it with the variable. That means you kind of can only call it once, which is what you expect to do. So that's a side effect of this shadowing, which I actually like. So none of no tag found. Git revision describe. Yeah. If I just give it the head commit, I can probably also just copy this. Commit ID. We don't actually get to call anything. Is that so? No, that's
Depends
not.
on what we put in, I think.
Yeah. It should, you know, I don't mind. It should traverse everything. We just give it head, but then, for example, no, nothing, an empty list here.
Exactly, yeah.
And then default would do it, huh? Hex length 7. Doesn't matter. Name doesn't matter. Okay, cool. So now, oh, what did I just do?
Oh no, this was the wrong one.
And that is none. Okay, undo this. Cool, back in business. Now one more test.
Yeah, name still missing.
Oh, this was up here and I removed it, or what happened?
Yeah, somewhere.
Oh, right. This I messed. This one is good now. This one wants this back.
Oh.
But this one should be default. Yeah, okay. Now should be a bit better. Good. Yeah, cool. Let's implement that first. So no candidate. Okay, none. I suppose. Huh? Yeah, I don't even have to sort it yet. Okay, 2 passed. The one that we just wrote is working. And now run this again, so we run into this issue. The sorting we are about to implement, it's not even anything we test, it's just something we implement. Because we only have one candidate anyway, or yeah, we just have one. Because we only provide one, right? So maybe it would be interesting to also provide more candidates.
Yeah, to have a specific test case for that.
Yeah, I mean, for now, it's probably okay to just make this one work, but we only have, yeah, let's just implement sorting on a list of 1. Candidates, sort by. Yeah, sort by key. We don't really have a key, we have 2 keys. So we have to
okay, so we need to
use a comparator. Candidate. Or am I wrong? Maybe sort by key actually, no, it returns the key, not the ordering. And this should give us, wait. Ah, yeah, that's the one with ordering here. For each candidate, or for each entry, it returns an ordering. Whenever I call these small functions, bisect and sort, I'm kind of puzzled these days. I don't know what happened. Is it a warning sign for early strokes or something? Or because I was expecting to see 2 items.
Yeah,
here.
Absolutely. If you need the item to compare it to, right?
Yeah. Look, what's going on? It's 2. Okay, I'm not quite there yet. IntelliJ seems to be claiming, or I'm misreading it, but does it automatically adapt or something? No.
Oh.
A and B is what I expect, but oh no, now it adapts. Look, oh, it gives me what I want. It tells me what I want to hear. That's not how this should work. Okay, so commits in its future. And that's the depth.
Oh yeah, that's right.
And then we compare that, and smaller is better. So since the default comparison is always ascending, this is exactly what we want. So AB, then whatever shorter is better. And then
this is when it's equal, then the then width will.
That's true. Yes. And if you can't decide by this key, use this one, which is order, also ascending. Lower values are earlier. that's that. What's the issue with order? Nothing. I would appreciate it if it could format this for me, but it can't because too many parentheses. Okay. Yeah. I mean, no surprise that with Rust you can be much more productive. Look at this. Like, okay, they've got qsort here, but then it's a different game. And look how many mistakes I can make here. Like, this requires a whole different level of experience to get right than this. You just have to know the ordering, what's where, and what this means, so to say. But once you know, it's ascending, I think it's pretty easy to figure out. And you will never have to ever say, oh, I want to do the reverse. I have to do B commits future comp A commits in the future. No, you always just do reverse and don't have to fiddle with that either anymore. So it's really, that's it. Comparisons solved thanks to Rust. Works. All right, then sorting is now done, and now the first candidate should be the one we want, huh?
Yeah.
And first can be an option, which is exactly what we have here, but not the right type or something. What's up? Result option outcome. Oh yeah, the outcome is not a candidate. The outcome is something else. Let's map this into an outcome. I've absolutely forgotten what that is, so let's see. Add missing fields, just tell me. Okay, so ID is commit, the initial commit, and I hope we didn't overwrite that or anything. And even if it did, we only shadowed it ever. So, and we never overwrote this because it's not mutable. So we know if it's not shadowed, it's the right thing. Hexlang just passed on.
It's information we should have.
But that's interesting. Am I missing something? Do we do anything with hexlang?
Yes, we do.
Right. The formatting, but it's the outcome. And this is why we pass it in here, because it must be set in the outcome, which is then the thing that is describing. It's the formatting.
Oh.
It's probably also something that's not clear, that the outcome can format itself. We are in git revision describe outcome, git revision describe format. We could call it format, and then it might be clearer that it's just what you format. I mean, it's better than outcome, but maybe there's better names.
Yeah, or you have a specific method. I mean, it's a bit counterintuitive because you have the toString or the display traits, but you could always have a specific method that takes in the hex length, and then you format the outcome.
I love it. I love that, because that, the reason we talk about this is hex language seems to be just passed through, and that means something is wrong. Something is wrong. And that's exactly what you want. You want the outcome to be an outcome, and then you can say format, and it gives you the format, which is then the thing that can display itself. Which probably does then have these things here. So format is this, and then outcome is this without hex length. And then formats is the outcome with hex length. And then
the display trait implemented.
And then the is exact match. Where do we even call this? It's probably something. Yeah, for now I would just say all this stuff is on the format. then this will naturally work. Then we just need something that transforms impl outcome pubif and format, or like path display, and then we can give it a hex length and return a format. Oh yeah, and there should be some instance of ourselves. Let's see, can we copy this, or is there some own stuff that we have to transfer? The name, yeah, this is not copy here. So this would be into display, because otherwise you can't do this. Hex length passed on, self-depth, self-long, oh. And the dirty suffix, that's always not none anyway. Somebody can set this later. Which means the outcome doesn't need a dirty suffix anymore. And the outcome also doesn't need long.
Yeah, okay, now having a separate type makes more sense, because I was
Yes.
thinking, do we need this extra type? But yeah, for this, definitely.
Yes.
I get it.
It's interesting, huh? It just forces itself onto you. You didn't even, like, nobody gets it right the first time, but then it kind of comes together. And into display does hexling. Yeah, that's it. Now a few tests will probably not build anymore, but we want to do this here, huh? First candidate should become an outcome. Candidate name is already the right type. Commit hexlang. Not needed anymore. Long, dirty suffix, all not needed, and death. Oh, that's the other one. That's the early bailout. Okay, here, this one. Okay, and it doesn't like much of that. Why is that? usize found flags. Right. But that's wrong. This counts commit. This doesn't have to be flags. This can be usize. Ah, but I made it flags because otherwise you have trouble doing the bit stuff. This is why it's U32. And that gives us more than 4 billion commits in a repository. I think we also save future-proof with that. So maybe just make this a U32 then. U32, U32, okay. Long is false by default. Cannot move CNAME, which is behind a shared reference. That's interesting. Ah, I don't consume this. I want the first thing, but I don't get it out of this vector because I just get it by reference.
Okay. Mm-hmm.
Okay. Now your turn. How do I get it out? How do I get it out of the vector? vecdeck. So.
Oh, you want to pop it? Oh, push it. Yeah, pop front, right?
Right. That should do. So now we sorted this, should be in the front. I would expect that. Because there's all the sending and all the important bits are then on the left, so that should be pop front. Method not found in vec candidate. What? Since when is that a vec? Okay, always a vec. It's not the queue. The queue is for IDs. Okay, got it. Well, then how do I do it? There's only pop back. There's only pop back, but not pop front. So I kind of want to iterate over it, but consume it at the same time. How do I do that?
So you would make literally make an iterator out of it. So the into version, okay, and then say, I don't know, nth or next. Yeah, that's because it's the first one.
Got it. But nth 0 could also be, I don't know, I mean, Clippy is probably the judge of that. But I think it will say nth 0, you just want next. I would think it tells me.
Easier.
Yeah. Yeah. But that's that. Yeah, that consumes the vector, transfers all of its items into the iterator, which can then pass them on one by one and move them out of the vector. At the end of this, the vector will be completely delocated, dismantled. And that's also nice, because that's exactly what we need and works. Okay. Has no field name taxling. Oh yeah, that's the tests now.
The failing tests, yeah.
That's what I just outsourced. Output format. Describe format. I think now we can call it format again, because now the type we test is literally describe format. Is it? Is the
describe format, yeah.
Is it really that good? Like that matching? Yeah, it's that good. It's the Git revision describe format. Wow. Jeez.
I want it to be.
It wanted to be just that. Okay, wait. Now we have an outcome. We create a format from that. We can do that just for fun, maybe just once. Into display. Yeah, I don't know, into display or into, I think, you know, I think it should be into format, because you know, you have a path and you can say path display, and that gives you a borrowed thing that displays the path. But here we don't pass any borrows. Here we transform, here we consume the outcome and put it into a format. So it should be into whatever you transform it into format.
I agree.
Okay, hex length is 7. And then the rest should be fine. We just have one test here. Really? I think it tests everything.
Yeah, exactly. Not split up, yeah.
Okay, fine. And now we don't need that. Don't need that. Oh. The outcome, much simpler now. Interesting, huh? You write this and have all these extra fields that are just used for formatting, and you say, yeah, well, it has to be, right? It implements format, so what can you do? And now we just, as a flyby thing, did exactly what we need to do.
Very nice.
Ooh, and everything is green.
Beautiful.
Beautiful. Beautiful in many ways. So much better. Refactored, and it seems to be running. Okay.
So what are we testing now? Actually, we have we give it one name, and we're getting the right depth from that. But it shouldn't actually matter, I guess, if we give it multiple names, right? Because it just finds more candidates, but the depth computation should be correct. So
yes,
I don't know.
we can make it a
Maybe
bit
that's the next
harder.
test.
We can make this a bit harder and give it another name that would be further away, for example. Should be easy to debug or find out. Git revision, test fixtures, this one, git log. So we have etc5. So we could give it etc1, for example. And if you say describe with debug, we see everything anyway. Ah yeah, describe head. Look, that matches nothing actually. Interesting. It matches nothing because it has no candidates. We have to give it all
tags. Oh yeah.
Yeah, tags, not all. Ah yeah. And yeah, 3C5. So that's exactly what we are doing. What I'm surprised about is that it doesn't show all the options here, huh? Ah, candidates 1. Now we see everything. Okay, so that's what I wanted. So look at this, at B1, C1. This one that is so close has 7. Really?
Yeah, what? No. B1, C1.
And we are asking for head. Describe us head. So describe us this one here. No, wait, describe us this one. And then it goes left, 1, 2, 3. So now it found it. Ah, yeah, right. It finds all of these too. Does it? It's interesting.
It again doesn't make sense anymore for me.
Yeah, it's a bit surprising. I mean, let's just do that, right? It's surprising, but it's the algorithm.
Yeah.
So we would expect, like, we can just debug print this for change and see what happens. So at B1, C1, that's this one here. At B1, C1. Oh. This one. And that name you don't expect to see again in the result, so we can just put the name here at B1, C1.
A dash, I think.
Okay. So that should still yield the same result. And it does. Let's print the candidates. Pretty sure it's going to be exactly the same as Git has. Print, debug print. Yep. Cool.
And now calling it commits in its future just seems completely wrong.
That's true. It's also the past, apparently. Okay, so we see 1. No, this we don't count. I mean, okay, first commit, second commit, third commit, fourth commit, we see this one. So fourth minus 1, so 3. This starts out at depth 3. And then we find this one. This starts out as depth 3 as well. And for this, for C1, C5, all these, they're not contributing because they're in its history. And for this one here, these also should not be contributing because they're in its past. Right? Like,
it is strange, yeah. Like I would agree.
okay. Then we get to this one. Then right. No, wait. I think the problem is we see this first. And then we see this. But the thing is, the traversal of these happens here. Happens as part of at C5. And thus, yeah, it's not like initially the first run, it probably didn't see that, it doesn't know that candidate, or it knows that candidate, but it doesn't know that it's actually in the future of these as well. It doesn't know this yet, because then when it processes the parent of this one, it sees this commit, and it knows it has seen these already. And then all that happens is that this commit gets the flags of this one. So in that moment, this commit learns about the presence of this tag. But it's not allowed to traverse because it's already too late. Because it traversed already. It traverses twice. It traverses once here, and it only knows at 1 C5, and then it does the counting or not counting. And it knows this one. It knows this one too already, apparently. This is why it counts it up. Okay, fine. But it shouldn't count it up. But it doesn't know yet that the flags are not set yet for these parents. But then the next time it comes, I don't know, man. It should. No, I'm wrong, because it's doing it stepwise as well. It's doing these two, first this one, then this one, then this one, then this one. So a few commits are always traversed without the proper identity set or something. But it already increments the counter for this one. And then once we are here, it sees the parent, it sees this parent, and then it will set the flag on this parent. But it will not traverse it anymore. It will not go down again or something. And also it will not, it's just too late. Like when this one sees this one, when this branch, so to say, when this side sees this commit, the left side is already a disk commit, for instance, or is already a disk commit. So it already is in the process of counting this guy up. But information about that this is actually in the future of this one has just been put here, but not here. The information arrives here too late, so to say.
Yeah. And then this branch stops. This one stops iterating because we've already seen it, and it goes with the other one.
Yeah, and nobody can change this. Even if we would traverse it again, then we simply would not count up that one, but it has already been counted up previously when it reached these commits through the left side. Which also kind of means that I don't know how correct that result is. Like if after all this traversal, that's what you get, 7, then to me that seems a bit strange, you know. The good thing...
Yeah, strange.
Also, doesn't this mean... Wait. At B1, C1, if you provide that, what would I expect if I see this? I would still think I'm 1, 2 in the future of this one. And I would select this tag and not this tag. All right? Totally. So I'm telling you this, like, it makes sense why I think it makes sense why we get this outcome, but I don't think it's correct.
Same, exactly. Yeah. I understand why it happens, but it just seems off.
Yes.
And then I thought maybe it has something to do with computing some sort of unique value, but that's not true because at C1 gives exactly the same. And that's just, it seems incorrect.
Yeah. Yeah, that's true. Even if you compare it like this, right, logically, like these are in totally different positions and this should not be the same, but it is. And we get the same results. Our algorithm works perfectly, so to say.
But I guess there is no other way to do this, right? Because you can, from a commit, you can see its parent, but does it work the other way around? Like, could you actually detect that merge? I think that's, you already said that's not really possible.
Yeah, I mean, you can, but then you have to build your own data structure that allows you to go the other way around. And then things might be different if you, like, I can't even foresee this. I can't simulate this in my head, but maybe it's different when you go from here and detect what's there, because then you have already discovered everything you need to discover, maybe, as opposed to going backwards. I don't know. Yeah, well, but they went through great lengths to implement it like this, and they even have this extra finalization step and all this, you know, special cases to quote unquote not do surprising behavior, which people don't expect when they do this. So yeah, it's okay. The last thing I want is to implement these standard algorithms. They're just what they are. To fix them, right? Like GitOxide could come up with a better way of doing this or a different way, but I think given that this has been in use for 11 years and deemed good enough 15 years, I think this has sailed. There's more value elsewhere, but that's great because this means that we've got a bunch of tests working and we can add more. We can add more special cases and hopefully a test for that as well, or at least add the special cases, which I really don't like if you don't have tests, but yeah, it's something to discuss another day for sure. So productive day today. Thanks a lot. Thanks a lot for watching and see you next time. Bye-bye.
Bye-bye.